Hello everyone, welcome back again to our channel Podisake. In this tutorial, we will be learning about the third part of C++ operators, which will be totally dedicated to bitwise operators, as I told you earlier, right? In our previous two parts, we have learned about all the other operators. In this part, we will be totally concentrating on bitwise operators, okay? So before starting this video, I would like to request all of you to please like and share our videos with your friends and family. And also, if you really like the content that we are bringing to you, please don't forget to hit the bell icon and subscribe to our channel so that you receive notifications regarding our latest updates. Thank you. So let's get started. As I say, today's topic will be the third part of C++ operators, which is bitwise operators. Okay, so let us go back to our PPT that we have already seen in the earlier tutorials. So let me just do one thing. Let me make it full screen. Okay. So as you can see, this was the PPT that we were referring for our last two tutorials, right? So we have already covered the definition of operators and then the various operators. Out of that, we have covered arithmetic, relational, logical, assignment, increment, decrement, ternary, comma operators, right? And as you can see here, this one, the bitwise operators was pending, and I told you already that we will be covering this dedicatedly in the third part. So today will be that. So as you can see here, arithmetic operators, relational, logical, assignment, increment and decrement, and ternary, we have already covered. And also we have covered the comma operator, right? As you can see, we separate two variables by using the comma, right? We have already discussed all these things in the last tutorials. Guys, if you have not referred those videos, please go to the playlist and I will give you the link in the description and also in the I button so that you can refer them. And if you have any doubts, you can ping your doubts in the comment section. And after that, after referring those videos, come back and carry on with this video, okay? Because otherwise you'll be having some doubts, so I want you to go back and learn and understand those videos and come back and get on with this video. Okay. So today we'll be starting with bitwise operators. So what do you mean by bitwise operators? Okay, guys, as you can see here in the definition, don't worry, I will give you a proper explanation and idea about how to work with this. And at the same time, I will tell you one more important thing. This is very important for IT students, bitwise operators. Many people still get confused about this operator and the functionality and how to use them. Okay, today I will be giving you a very deep introduction and also I'll be showing you lots of programs on this so that you can understand the base and you can be very clear about how to answer about this in the interviews. Okay, so as you can see in the definition, bitwise operators are used to perform operations on individual bits of a value. Okay, so to be even simpler, I can say that the individual number will be converted into a bit or a binary value. Okay, then on that individual bits of the binary number, we will be performing certain operations. That's why these operators are known as bitwise operators. Okay, so first, let me take a pen and write down for you. This is a simple idea I'm trying to give you here. Okay, so try to understand that. Okay, suppose I have a number, say n equal to 20. Okay, so this first has to be converted into bits or into a binary number. So suppose I can say, I hope you guys know how to convert a number to binary, right? This is a decimal number, guys. Okay, this is a simple decimal number and you have to convert it to binary. Okay, so for that, what you do, simple, just remember this series of numbers: 1, 2, 4, 8, 16, 32, and it keeps on going multiplied by 2. Okay, so whenever you have to represent any number in this binary bits, what you do, you calculate the addition of this certain numbers and do it. Okay, so suppose I have to represent 0, I will say 0 0 0 0 because 0 is not available in this series that I have given you. Okay, so similarly, if I have to represent 5, I will say, you can see here, right, 5 is also not present in this list. So what I do, 4 plus 1 can be said to have 5, right? So I can say 0 Wherever you are adding those numbers, you will put 1, 0 and again 1. So this will be 4 plus 1, 5. So 0101 will be the binary equivalent of 5. Okay, got it? Similarly, now we have 20 in our example. So what we do, we take it something like this. You can see here, I don't have directly 20. Okay, and guys, please remember one thing. These numbers that you see here, they are actually the power of 2. So this 1 is actually 2 power 0. This 2 is 2 power 1. And it keeps on going like this. This 35 is 32 is 2 power 5. And it keeps on going like this. So in each number, it will be 2 power n plus 1. It keeps on increasing like that. Okay. So as I said, I have to represent 20. Now you can see here we have 16 and 4. So I can write it like this. 1, I said wherever we are adding the numbers, we will make them 1. Okay. 1 means in binary true, or you can also say high. Okay. Or you can also say true. And similarly, 0 will be false because computer only understands binary, right? So I can say 16 plus, this will be 0, this will be 1 and 0. Okay. So this is the binary equivalent of 20. So decimal number 20, this is the binary equivalent. 10100. That implies like this. This is 16 plus, this will be 0 plus this will be 4 plus 0 plus 0. That is 20. I hope you have understood this. This is how we calculate binary of a decimal number. Okay. So now at least you have got a basic idea of how to interact with decimal numbers and convert that to binary, right? So bitwise operators, these operators actually convert the decimal numbers into binary. Okay. So it will be decimal to binary. Then on the individual bits, like you see here 1, 0 and all, the bitwise operators work on the individual bits and then perform certain operations. Okay, based on that, you can see here. Let me convert it again to the laser pointer. Okay, you can see here bitwise operators are used to perform operations on individual bits of a value. Okay? Value, as I said, it will be a decimal number. Okay, these operators are commonly used in low-level programming. Okay, such as working with binary data or hardware manipulations. So, as I said, it is very important for someone who is doing low-level programming, so just like microprocessors or microcontrollers, and also at the same time, if someone is making any changes to the hardware, then this operators are very, very important. Like suppose there is a toggle operation or any other operation like that, we use the bitwise operators for that. Okay, so I hope you have understood this, and based on that, here are the common bitwise operators in C++. Okay guys, these operators are actually common in all the languages, and the logic is absolutely same, be it Java, be it Python, be it C++ or C. Everywhere the bitwise operators logic is same, only the syntax and the way of representation is a little bit different. Okay, so you don't have to worry about that. Just understand the concept in one language, and you will be good to go in any particular programming language. Okay, so based on, as I said, here are the common bitwise operators in C++. So bitwise AND, bitwise OR. This is the ampersand symbol. This is the pipe symbol. Bitwise XOR, which has the caret symbol. Okay, and then bitwise NOT. This symbol, the tilde, and then we have left shift and right shift. So these are the 6 operators that we will be talking about. Okay, so let's directly go to the Microsoft whiteboard so that I can show you certain examples, and so that you can understand easily about bitwise operators. And also simultaneously, after explaining in the diagram, I will be showing you some examples and code snippets so that you can understand about that. Okay, so let's directly go to the whiteboard. Okay, so guys, as I said, we have 6 bitwise operators. We will be starting with all of them one by one, and gradually I will be showing you examples on all of them. Okay, so let's start with bitwise OR. Okay, and as you know, the symbol is this pipe symbol, the straight or the vertical part. Okay, say I'm taking 5 and 10 as the numbers. Okay, simple. let us convert them to binary. So for that, what I will do, side by side here, I will write down the series of the numbers that I had here: 1, 2, 4, 8, 16. Guys, I know how to convert directly to binary, okay, but for you guys, I'm just making it simple: 32 and 64, right? So 5. So it will be 4 plus 1. So I can write 0, 1, 0, 1. Okay. This will be equivalent of 5. Okay. 10. So 10 will be 8 plus 2, right? So it will be 1, 0, 1, 0. Okay. This is 10. Right? I hope this is making sense and you are trying to understand that. Okay. So here I will simply write it down like this: 0, 1, 0, 1 and 1, 0, 1, 0. Okay. So now, as we know, OR means in logical and or operations, we have learned about the table, right? Let me give you the table again so that you can remember that. So I will simply take 0, 1, 1, 0 and 0, 0 and 1, 1. Okay. So 0, 0 for OR it will be 0, or we know, right? At least if one of the inputs is 1, then the output is 1. Okay. 0, 1 will be 1. Similarly, 1, 0 will be 1 and 1, 1 will be obviously 1. Okay. So based on that, let us try to write it here. And okay, let me do one thing. Let me erase this from here and let me write it a little bit down so that you don't get confused. Okay. So let me do this again and let me write the table here. For okay. So or table. Okay. So 0, 0, 0, 1, 1, 0 and 1. Right? 0, 1, 1, 1. Right? So based on that, let us see here. 1, 0 will be 1 and 0, 1 will be 1. This will also be 1 and this will also be 1. So this is the final answer. Now let's see what it is actually. Okay, 1, 1, 1, 1. Let us write it here: 1, 1, 1 and 1. So as you see in the numbers, 8 plus 4 is 12, plus 2, 14, plus 1, 15. So this is corresponding to 15. Okay. So 5 or 10, whenever we are doing, we are getting the answer as 15. Right. So let's go to our ID and try to understand and see if we are correct or not. Okay. Now what I will do, I will take int A is equal to 5, int B is equal to 10, and I will say int C is equal to A bitwise or B. Okay, then I will simply say cout T. Okay, now as we saw in the example, we are getting 15 as the answer, right? Let us run this and check. Yes, guys, you can see. So I hope you have understood this about bitwise or means whenever at least one of the inputs is 1 or high, the output is high. Okay, now after this, let us go to bitwise and. Okay, so for that, what I will do is I will take it here only. Let us take a simple example. Say I will take some different numbers. Okay, say 6 and let me take 7. Fine. And 6, as you can see here, it will be 4 plus 2, right? You can see here 4 plus 2. So it will be 0, 1, 1 and 0. For 7, it will be 4, 5, 6 and 7. So this has also to be added. So 0, 1, 1, right? So this is 6 and this is 7. Correct? So we have figured out the numbers or the binary bits. So I will write it like this: 0, 1, 1, 0 and 0, 1, 1. Okay, and you already know the data. So whenever both the inputs are high, then only the output is 1, right? So this will be 0, this will be 1, this will be 1 and this will be 0, right? So you can see that this is matching to our input 6, right? So 6 and 7 gives us the output when we do the AND operation as 6. Let's try to verify in our IDE. Okay. Now let us take the same thing only. I will write 6 and here I will write 7 and let us do AND operation. Okay guys, if you do double AND, guys, please remember this will become logical or AND. Okay, if you do double pipe symbol, this becomes logical OR. Same thing, if you do double AND, it becomes logical AND. But I am doing bitwise AND. Okay, the symbol is single ampersand. Now, as we saw in the output, the answer was 6, right? Let's run this and check. Yeah, guys, you can see here the answer is 6. So it's working absolutely fine. Now we have covered two bitwise operators. Let us go to the third one. Okay, so let us go to the whiteboard again and let us try to solve the third one. Okay, so I'll just drag it a little bit up and we'll start with the other one. Okay, so now it's turn for bitwise XOR. Okay, so for bitwise XOR, guys, I will give you a very simple explanation so that you can remember it lifelong. Okay, people tend to otherwise forget this. Okay, just remember this. This logic is more than enough for you. Input bits, whenever the input bits are same, the output will be 0. Whenever the input bits are different, the output bits will be 1. That means you can simply understand by this, right? Whenever the input bits are 0 0 or 1 1, then the output will be 0. And similarly, if it is 0 1 or 1 0, when they are different, not matching, then the output will be 1. Okay, so let us try to follow this logic and try to solve any simple example. So I will take say 8. In binary it is 1000. Now guys, if I write the values, I think you can figure it out. You can otherwise go to the table and try to calculate if you are not understanding. You can simply go to this table that I have here. Okay, here as I showed you earlier, you can just go to the series of numbers and you can calculate the binary. But because I hope I have explained properly, you can easily understand and calculate it. Okay, so I'm taking 8 and say let us take 11. Okay, so 11 will be 1 0 1 1. Okay, 10 plus 1 11. Okay, so in this case, let us try to follow this logic. Same 0 and different 1. Right? 0 and 1 you can see here, guys. 0 and 1 is different, so it will be 1. 0 and 1 again different, 1. 0 0 is same, so same 0. When the input bits are same, it will be 0, and here also 1 1 is same, so it will be 0. Right? So this is the final answer. So this is 2 plus 1, that's 3. Okay. So when we do bitwise XOR of 8 and 11, the output is 3. Let's go back to our IDE and try to solve this. Okay. So one was 8 and one was 11, right? And let us change the symbol. This is the cap symbol or the caret symbol, guys. Let's try to run this and check. The output was 3, right? Yes, guys. See, we're getting the answer. 3. Fine. So I hope you have understood this. Just remember it, when the input bits are same, the output is 0, and when the input bits are different, the output is 1, as you can see here, right? Just remember this and you will be good to go with XOR operations. Okay. So and this XOR operator is used in many arrays and other programs in programming to find the non-repeating element and many other operations. Okay. Otherwise, guys, actually bitwise manipulations is very important in coding, and in our next further videos we will be learning more operations in bits so that we can actually solve complex problems using bit manipulations. Okay, we'll do that also, don't worry about it. For the time being, let us focus on the other operators that we have. Okay, so we have covered AND, we have covered OR, and we have covered XOR, right? Now let us go to the right and the left shift operations, and then we will finally go to the bitwise NOT operation. Okay, so let me just drag it a little bit up. Fine. So here, let us start with the shift operators. Okay, and they belong to the bitwise group. Okay, Here we have to right and left. Okay. Based on that, the symbols will be, this will be towards the right and this will be towards the left. That's it. Okay. So guys, while we are dealing with bitwise shift operations, just remember one thing. You will be given the unit or the step. Right? Say suppose I am taking a number a is equal to 10. Okay. And you are given step value is equal to 2. So what does this 2 mean? This means that you have to either go 2 steps to the right or 2 steps to the left. Okay. You have to shift the bits by 2 bits to the right or 2 bits to the left. I'm just taking an example. This value can change. Okay. Depending on the question, if this value can change. Okay. So let's take 10 as the number here. Don't mind my drawing. I'm not so good at drawing. So I will try to draw a 8-bit representation of 10. 1, 2, 3, 4, 5, 6, and 2 more. Okay. So I will say 0, 0, 0, 0, 1, 0, 1, 0. So first of all, let us do the right shift. Right. So the step given is 2. So you will be getting like this. A right shifted by 2 units. Right. So simple guys. I will just do it like this. Try to understand. Okay? It's very easy if you understand and focus. Okay. Just try to see what I'm doing here. 1, 2, 3, 4, 5, 6, 7, and if we take one more, 8. Okay. So same thing I will draw from here. 0, 0, 0, 0, 1, 0, 1, 0. Okay. So we have ultimately shifted the 8-bit representation of 10 towards the right. You can see here by 2 units. Okay. So here this 2 bits that you see will be discarded. Right. So what I will do, I will take a different color now. So let us take red, and here I will simply say this two are not required. Okay. Now what you do, you just draw 2 extra boxes here. Fine, like this. So 0 and 0. Fine. So this one here will be the final answer. Okay. So based on that, you can say that this is actually 2, right? 2 is the final answer. So whenever we shift 10 to the right by 2 units, the answer is 2. Okay. So you can see that whenever we are going to the right, the value actually decreases, right? Generally, when we do right shift, the value decreases, right? So let's go to our IDE and try to solve this. Okay. So here, let me take 10 and I will write simply here A right shifted by 2 units. And here, because in C++, this symbol is also used for taking input from the user. What we do is we can give a bracket like this so that the compiler does not get confused. Okay, whereas otherwise, because sometimes what happens, I will show you what is actually happening here. I take a value int n is equal to, I'm just taking a value, okay, then I will say C in n. You can see here, actually it is used to take input from the user. Okay, just like we have printf and scanf in C programming, here C in and C out are used to take input and output, right? So you already know about this because I have told about this in the earlier part of our earlier videos, right? So let us not get confused with this right now, and just try to remember that if we don't give this bracket here, the compiler will throw a compilation error because these arrows actually represent input function in the C++ programming language. So we have to give a bracket here so that the compiler does not behave in a different manner. Okay. Now let us try to run this. As we saw, 10 when it was right shifted by 2 units, the output was 2, right? Let's run this and check. Yes, guys, you can see here, right? We're getting the proper output. Okay. So generally remember, when we go towards the right, when we shift the bits towards the right, the value generally decreases. Okay. So this was the diagram and this was the explanation. Now, I hope you have understood this. And guys, I'm trying to keep it very simple. If you have any doubts, please bring your doubts in the comment section. I'll be happy to clarify all those doubts. Okay, now let's do one thing. Let's scroll even a little bit more up and try to do it for the other way around. Okay, so we have already seen right shift. Let us do one thing. Let us draw the same diagram in a different way. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, I will take now 10 left shifted by 2 units and let's see what we get. So I will simply write 0, 0, 0, 0, 1, 0, 1, 0. Right? So simple. We had to shift 2 bits to the right in the right shift operation. Now I will be shifting 2 bits to the left. That's it, right? So what I do, I will simply say, I will be starting drawing from here. Okay, something like this. 1, 2, and here I will draw only 6. That's all. 1, 2, 3, 4, 5, and 6. So 0, 0, 0, 0. Same data. Whatever I have on top, I will write the same thing on 1, 0, 1, 0. But I am shifting the 2 bits to the right. That's all. Now, as you can see here, these 2 bits that you see here are discarded, right? This will be discarded. So as we have discarded them, what we do? We go to the right hand side and we add 2 bits here. Correct? 0 and 0. So this will be the final answer, right? So let us try to write it like this. So let me give you a simple example. I know the answer is 40, but for you, I will just write it like this. 1, 2, 4, 8, 16, and 32. Right? So I will only take the bits like this. And let me write like this, 64 and 120. Okay? So 0, 0, 1, 0, 1, 0, 0, 0. Right? So we only have to add 32 plus 8. Right? So it is 32 plus 8, that is 40. So when we do 10 left shifted by 2 units here, we get the answer as 40, right? So as I said earlier, right shift, the value will decrease. Okay, and if you do left shift, the value generally increases. Okay, please remember that. So you have understood this, right? I hope there is no problem. Let us go to the editor and try to verify this. Okay, so this time around, what we will do, we will take the other way around. Okay, so it will be something like this, left shift. Let's run this and check. Yes, guys, you can see here we're getting 40 as the answer. Okay, so with this we have covered the 5 important operators in bitwise, which are AND, OR, XOR, right shift, and left shift. Now let us try to do the other one, which is the bitwise NOT operator. Guys, the NOT operator is very simple. Let me just go ahead and tell you the logic about that. Okay, so what I do, I will just drag it a little bit more up. Okay, to start from here. Fine. So what I take, I will just write it down like this, bitwise NOT. Right? So we already know the table, right? Or not? It's very simple, guys. When we learned about logical operators, we learned about this, correct? So when we have 0, it becomes 1. When we have 1, it becomes 0. Or we can also say like this, if it's true, it becomes false. If it's false, it becomes true. That's it. So it's negation, the reciprocation or the reverse of what value we're getting. Okay. Suppose let me take a simple number like say I'm taking 5. Fine. And we know the symbol, right? First of all, let us write the binary. It is 0, 1, 0, and 1. Correct? Now, let us try to do not of 5. Okay? This symbol, guys, this symbol is called tilde. Tilde. Okay? So, not of 5. Let's try to do this. So as you can see here, 0 becomes 1 and 1 becomes 0, right? So based on that, let us write it like this. This 0 will become 1, this 1 will become 0, this 0 will become 1, and this 1 will become 0. So based on that, we can see that the binary value coming is equivalent to the decimal value 10, right? So when we do not of 5, we should get the answer as 10. Now let us try to verify this. Simple, right? We are doing negation. So let's go back here and I will take int a is equal to 5. I will say cout tilde sign or the negation operator and not of a. We'll simply write this. Okay. Now let's simply run this and check what we are getting. Okay. Whoa, guys, you can see we're getting something different, right? It's minus 6. Now what's happened? Getting confused? Even I am. No. I'm not getting confused. I know the answer. Don't worry about that. We have minus 6, right? So let us try to analyze and try to understand what is happening. Right? What we will do, let's go back to our whiteboard and try to understand. Okay. So when we did this not of 5, we were supposed to get 10, right? But what are we actually getting? We're getting minus 6. Okay. So you just remember one thing. When we do bitwise not, okay, that is reciprocal or negation. Right? Now the problem is our compiler, it cannot store negative values. Okay, just remember that. And I'm giving you this answer for theory and your technical rounds. Wherever you get this question, you can answer it like that. Your compiler cannot directly store negative values. Okay, so what we do, we take the negative value minus 6 and take the positive or the absolute value, okay, abs. So ultimately it will become 6, right? Now let us convert 6 to binary. So this will become 0 double 1 0, right? Now what we do, we take ones complement. So that means just the reverse. 0 becomes 1, 1 becomes 0. Okay, and then we add 1. That means it will be 0 0 0 and right. Now let's see what we get. 1 plus 1 is 10, right? And the carry will be 1, and this becomes 0 and okay. So you can see here we are getting the theoretical value, right? And this answer can be told in the tech rounds, right? But suppose, imagine that you got the idea, right? I'm telling that your compiler cannot store negative values. So what we do, we take the absolute value 6, convert it to binary like this, do ones complement and then add 1. Combining that, we get this theoretical answer 1010, which is the answer 10 we are looking for, right? Not of 5 equal to 10. But this will not be enough for MCQs. Okay? In MCQ round, you will get it something like this. Let us go again here and try to understand this. Okay? Suppose I'm giving you a simple question like this. Say I'm giving not of 5 and I'm giving a say 10, or let me say 11. I don't have the 10 option. B equal to 6, C is equal to 5 and D is equal to, I'm giving minus 6. So you will go to the editor. Here you can see in the console we got the answer as minus 6, right? So obviously you have to choose this answer, correct? Minus 6. Now because we have to be correct in the decision making, right? So obviously I have to choose this as my answer, which is the correct answer. So this is wrong, and this is also wrong. Now how do you choose this? There should be a general rule also, correct? What we do it like this. Suppose the number is n is equal to something, anything, 5, whenever we do not of n, the general rule is not of n is equal to minus n minus 1. Okay, so when we have 5, we write it like this: minus 5 minus 1, that is minus 6. Okay, but one more scenario I'll give you. Suppose the number itself is minus 5, then what will you write? It will be minus 5 whole bracket of minus minus 1. That is, minus of minus 5 is plus 5, right? It will be 5 minus 1, that is 4. Okay, so this is the general formula, guys. Please remember this. For MCQ rounds, you have to follow this one only. You cannot take the theoretical one. So if you get the theoretical one, just remember it like this. As I said, you can go here and understand this. Let me just reduce the size a little bit. Okay. Okay, as I told you earlier, your compiler cannot understand negative values and cannot store it. So what we do, we just take the absolute value like this, you can see here, and then we convert it to binary here, and then we take one's complement as you see here, and then we add 1, and then we finally get the theoretical answer. And please remember, one's complement plus 1 as you see here is known as 2's complement. Okay, therefore bitwise not is also known as negation of 2 or double negation. Okay, or it is also known as 2's complement. Clear? So now I hope you were clear about this. Now let's go to the IDE again and try to verify what we have just learned in theory. Okay. So what I will take, let us take any number, 50. Okay. And as I told you the logic, it is minus n minus 1, right? So minus 50 minus 1 should become minus 51. Let's run this and check. Yes guys, you can see here, right? Minus 51. So this is about the bitwise mount. Now let us take a different number. Say I am having minus in the number itself. So minus like this. So it should be something like this, right? Minus of minus 50 and then minus 1. This should become 50 minus 1. That is 49. Let's verify. Run this. 49. Yes, makes sense, right? So I have given you both the ways how to answer in the theoretical rounds and also in the MCQ rounds. Okay, so I hope you have understood this. Guys, this is all about all the 6 bitwise operators: and, or, XOR, right shift, left shift, and the bitwise NOT operator. These are, guys, very important concepts. Please remember them, and if you have any doubts regarding that, please don't forget to ask me in the comment section. I'll be very happy to clarify all your doubts. And guys, if you have liked this video, please don't forget to share it with your friends and whoever wants to learn programming and about bitwise operators. And if you really like this content, please don't forget to subscribe to our channel and hit the bell icon so that you can receive notifications about the latest updates. Okay, and thank you guys for your support. I hope you'll be supporting us in future. So till the next time, this is Saurabh signing off. Thank you and happy learning. Bye bye.